and we choose points K and L inside triangles BMC and BNC. So that what's L? Oh, okay, K. Okay, K. Okay, hold on. K is in triangle BMC, and L is in triangle BNC. So K is inside the angle LB. Okay, that makes sense. And L is inside the angle ACK. Okay, so K is here, L is here, AC. What? Yeah, kind of. I don't even understand the question. What? Okay, so K is inside the angle LBA, and L is inside the angle ACK. Is that even possible? What? Um, yo, um, um, oh, fine. So you have K like this, and L like this. So like K is inside the angle ABL, and L is inside the angle ACK. Okay, yeah, fine. So we can find points K and L. So the K is inside the angle ABL, and L is inside the angle ACK. Okay, fine. And we have some weird looking angle conditions. So K KBA equals ACL. Okay, and LBK LBK equals LCK. Okay, okay. Oh no, no, wait, what? Equals LNC. Okay. And LCK LCK equals BMK. Okay. Very unusual to say the least. O is the circumcenter of AKL. Prove that OM equals ON. Okay, okay. So okay, from our practice of solving IMO 2009 problem 2, we know that what we need to show is that M and N have equal powers with respect to circle AKL. And this is true because, I mean, power of points is ON squared minus the radius squared. Okay, so we need to find a way to use these angle conditions somehow. Right. So let's get a triangle. Okay. And no points. Yeah. And okay, so we have points K and L kind of like this. Like something like that. We have these very strange angle equalities. Okay. So let's just double check. So KBA equals ACL. Okay, that's quite interesting. LBK equals LNC. Okay. Doesn't look true on my diagram, but yeah, and LCK no, LCK equals BMK. Okay, wow. Yeah. 100% this is already harder than last year's Geometry P2. Like, yeah. Already you have these really strange angle conditions that we need to use. Okay. So I think once we find a way to use these angle conditions, the problem should be fine. Yeah, it shouldn't be that bad. Hopefully. LBK equals LNC. What the like? Oh wait, hold on. Hold on. What if M and M both have power of point zero with respect to AKL? Well then, okay. If hypothetically, like with our wishful thinking, hypothetically, if AMKLN was cyclic, we'd be done. Yeah. Okay. Is that necessary from these conditions? That's what we need to show. Hmm. Okay, so we have midpoints. When you have midpoints, really there are two things you can look at. You can look at constructing parallelograms, or you can look at some sort of homosity. Here, and then enlargement scale factor 2 from A looks kind of nice. Um, kind of nice. So if we okay, we have some equal angles, so I want to try and bring them closer together because right now, like you have one angle like here, one angle here, and they're equal, and it doesn't really help me with anything. So we want to try and move them closer together somehow. Okay, quite a random observation. If you extend CL to here, some random point like X, you have that XMKC is cyclic. But that doesn't really help us with anything. Yeah, this is no joke for Form 2. Like already I can tell that this is definitely on the hot this is I think this is very hot on the day one from what I've seen so far. Like yeah. Yeah, I think this is probably the hottest day one in recent years. Definitely. Like on Austria's day one at this point I have solved problem one and two already. Like this is probably hot day one. So uh but- so let's construct a point K. And okay, so now we want to construct a point L. Okay, well, angle BKM is 180 minus angle KCA. Ah, okay, so if I reflect K over M, this is what I meant. If I reflect K over M, so it's called K prime. Yes, okay, so then we have, since AMK plus KCA, yes, since BKM plus ACK is 180, and when we reflect this over, we have that angle MK prime A plus angle ACK is 180. So we have this cyclic quadrilateral here. Okay. Yeah, that's quite good. Okay. I think we should definitely use this. Yeah, this is very nice. Okay. 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 Yeah. Okay. So let's get a good diagram going. Yeah. And then we reflect L. Okay. And we have that ACKK prime is cyclic. We have that ABLL prime is cyclic. And really that's it. Um, yeah, that's it. Okay. Yeah. Wow. Yeah, not an easy problem to at all. Wow. Yeah. Okay, so which conditions have we used? We've used the angle. We have used the angle conditions. We have used the midpoint conditions, but I feel like we haven't fully exploited the angle conditions quite yet because we've used a weaker statement, that angle C, that angle KCN plus angle BKM is 180. That's a weaker statement than what we're given in the problem. And wait, another thing we need to understand this circle AKL because again, that's what the problem boils down to, and we don't really know much about this circle. Oh. Again, wishful thinking. Maybe A K prime K L L prime is cyclic. But if that were true, and M and N have equal powers, then we'd have that NL equals MK. I don't know, this is feeling more like a P3 than a P2, to be honest. Like, yeah, this is feeling like I'm solving a P3. Oh no, yeah, that's stupid. You can't have A K prime K L cyclic because we have A K prime K C is cyclic. Yeah, that's not happening. Yeah, this is no joke for problem for B2. Okay, let's think more about points K now, because that's what the problem is about. And we have this weak condition that that at least for K, given the midpoint of AB, if we select K and we reflect it over to K prime, then these are cyclic. I feel like this is quite an interesting condition. Yeah, I feel like this is something we should look at in more detail. Like what different points will satisfy this. It's giving kind of similar vibes to the RMM problem 5 from this year, which I didn't solve either. Like it's giving similar vibes because yeah, you have like two random points inside the triangle ABC and you don't really know what to do with them. Okay. Yeah. Yeah, this is yeah, I feel like this is more like a P3 in terms of like what my feeling is because like this seems there's no like obvious way to even construct the points K now. At least to me, there's no real obvious way to construct the points K now. Okay, I mean, if we do moving points, I mean, I learned moving points literally like 2 days ago. So I don't know if we're going to use moving points on this question. And to be honest, I don't remember the stuff that I learned. I need to relearn it. But I feel like I mean, moving points was useful in the RMN problem 5, so maybe it'll be useful in this question as well. But yeah, I don't remember the technique. Like I remember, like basically what you do, you got count degrees, and then you count the degree of the statement, and then you need to prove it, whatever that degree is. That's the number of special cases you need to prove the problem in. And if you prove the problem in that number of special cases, you prove the problem for like always, not just in the special cases. But yeah, I forgot how to count the degrees, so yeah, we can't really do that here. Okay, so the one construction we got, the one like bit of progress we had, is to put these points K prime and L prime. And yeah, so we want to. What are we actually trying to? We're trying to use the animal conditions. That's what we want to do. We want to use the animal conditions in some nice way. We've done that to an extent with these constructions, but we haven't fully used them yet. Yeah. Okay, I feel like um We're like extending past K. Let's call it point B1. Let's call this point C1. I don't think this is the worst idea. Yeah, because by parallelograms, we have that AL equals L prime C, and then when you extend it, you have L prime C1 equals L prime C, and that the lengths are parallel, so this is another parallelogram. Yeah. Is it a useful parallelogram, though? That's a different question. Hmm. Hmm. Yeah, these angle conditions are so weird. Like, yes, it's so unusual. Yeah, I don't wanna miss any ideas I'm thinking of. So, any idea I think of, I'm just gonna try it and see if it leads somewhere. So, I think the kind of bad idea I'm having, one that I don't think is gonna help me that much, is if we just like if we extend BK and CK to the length of the triangle. I don't think this is gonna help that much, but let's just see. Because like the reason for this is you get like some cyclic quads. So that's my thinking. So let's call this like C1, and then you have um like L somewhere, and you have like you extend CL. Let's call this one C2, and you extend BL, and you get B2. Angle conditions are like this thing, and okay, let's put an M and N. Yo, what if N is the midpoint of B1 B2? That would be kind of crazy. Yeah, that would be crazy. Um, so we get like 10,000 cyclic quotes. Okay, so we get B C2 B1 C is cyclic. We get B B1 and L is cyclic, and we get C C2 and K is cyclic. Yeah, this is a crazy problem. This is crazy for me. I don't think there's been a P2. I don't think there's been a medium geometry question in IMO as difficult as this. Yeah, like in recent years, the hardest one, at least in the last, I mean, there haven't been many really, but in recent years there was the one in 2019 and the one 2023, and there was one last year. And the hardest one I would say was 2023. And even that was like, at least that one is quite easy to like make a start on and do some stuff. Here's just like what is going on? That's my reaction really. Like what do we do? Like this doesn't feel solvable with elementary methods. I mean, it has to be it because they've put it as IMO problem 2, so there has to be some sort of elementary solution. But I'm feeling like I'm not able to find one. Okay, random observation. We have NL is tangent to circle BC to L, and MK is tangent to circle CB1. I feel like these constructions are very weird, but I mean these cyclic conditions are necessary and sufficient. These cyclic conditions are necessary and sufficient for the angle conditions to hold. Yes, I think we've used all the angle conditions to create these cyclic conditions. So yeah, I feel like well at least let's try this for some amount of time. Partially because I can't think of anything better to do, and let's see if this goes in there. Like, I don't have too much hope, but maybe maybe it will lead to something. Oh, okay. Um, I think let's call this one C2. Instead, yeah. But then we get like B C1 B1 C cycle. Uh, it's just better. Okay. We have some random stuff with PowerPoint. At the end of the day, the question is about PowerPoint because it's the power of points M and N to circle AKL. So yeah, this can't be the worst thing in the world to look at. Okay, so what are our cyclic quads? Our cyclic quads are BC1, B1C, CC1MK, and BB1NL. And I think that's all we have. Okay, let's write down some PowerPoint stuff. So EC1 B1C cyclic. So AC1 times AB is AB1 times AC. Okay, B2N times B1 B2 is B2L times B2B. Okay, C2M times C2C1 is C2K times C2C. Okay, so this doesn't look very promising at all. Yeah, I don't think this is the play. Um, at least looking at my diagram, it kind of looks like N is the midpoint of B1, B2 as well. Okay, okay, let's suppose that's true. Then what do we have? Then do we get anything new? I don't think so. Okay, I mean, more than cyclic quads, we have a few similar triangles here. We have the triangle ABB1. It's similar to triangle ACC1 because it is. And like, let's put the reflections in as well. Because let's put the reflections and these quote unquote bad constructions. Let's put them in the same picture and see if anything random comes out of it. It should be a bit more like this, probably. Yeah, a bit more. Yeah, and the same with this. It should be a bit more like this. Yeah. Okay. This might be a bit messy for yeah people watching, but okay, more of it. If I reflect C1 in N, then these are going to be clear. Yeah, this is probably really messy. Yeah, this is really messy if you're looking at it all straight. Um, yeah, this is a hard G2. Definitely, this is a hard G2. Okay. If we can't solve a problem, let's try and solve an easier version of the problem. Okay. So when we have conditions like this, this whatever you call it, like ABK equals ACL. You kind of think about this sort of cyclic plot, C BC1 B1C. And a well-known example of this is you have the altitude, like the okay, so let's try and solve an easy problem. Let's assume that K and L are on the altitudes from okay, let's say your altitude is BB1 and your altitude is CC1. And let's assume that K and L are on the altitudes. And let's try and solve the problem in that case and see if that tells us anything. Yeah, so we have obviously we have these angles are equal, and the midpoints, yeah, the midpoints N and M. Oh yes, of course. We also have yeah. How do I not see it? By Rime's theorem? Obviously, we have the and then C1 B1 is cyclic as well. Completely missed that. Yeah, it's also about like the power of points thing. Like there are 10 million ways to argue it, but they are cyclic. And we have that we have these kind of again these random angle equalities. Mm, and again, these correspond to cyclic quads. So L is the point where B1N meets the line CC1. Oh yeah, so this actually gives us a way of constructing K now. Yeah, okay, so maybe this isn't that bad. Yeah, okay, let's look at the special case first, then we'll look at a more general case. So select points B1 and C1, B1 on AC, C1 on AB, and take the midpoints M and N, and draw the circle B1N where that meets the line CC1, that's L. Take the circle C1N where that meets BB1, that's K. Okay, so we have at least we now we have a way of constructing points K and L, which imply all the and of course M B C1 B1 C has to be cyclic to start with. But this way of constructing the diagram constructs K and L how we want them to be. Okay, so we have a way of constructing a perfect diagram, which is always useful. So I think these points C1 and B1 are actually very useful. Yeah, I think these points C1 and B1 are very useful. Yeah, so this wasn't a bad idea after all. Maybe C2 and B2 aren't great, but B1 and C1 are definitely very good. Okay, let's solve this special case. I don't like this diagram. So let's try to solve the special case, but on a better diagram. That's our next best course of action. Okay, and now we take the points. Which one is which? N is the midpoint of AC, okay. And M is the midpoint of AB. Right. And now to construct K, we have the circle B1N meets CC1 at which one is this? L, okay. I forgot. It's fine. L and then the circle C1M means BB1 at A. Okay, and now what's the thing? We need to show that M and N have equal power. Circle AKL. So it's like we need to understand what is circle AKL. Like, what is it? Like we like it's all well and good saying have equal power to the circle AKL, but what actually is a circle AKL? We need to know what that is first. Okay. I think GeoGebra would be very helpful right now, but I mean you don't get GeoGebra in the IMO, and I lost my ruler, so we're gonna have to try and solve the problem with these bad diagrams. I mean, I think I have a compass somewhere. I could find it, but yeah, I don't have a ruler, so maybe I could get like a pencil and use that as a ruler, but yeah. But I think we'll just stick to this for now. So we have these circles, and A is on the right axis of these two circles, because it is. Because MC1, B1N is cyclic. Now circle AKL. Okay. We show M and N have equal power with respect to circle AKL. Okay. Okay, so AKL. Okay, so if we drew the circle AKL, this is getting really messy. Um, yeah, circle AKL, and if that meets AB at C2 and AC at B2, and we showed that MC2 times MA is equal to NB2 times NA would be done. Oh, but MA equals MB. So if we show that MB times yo, is it enough to show that BC to B2C is cyclic? I think it might be, Um, think it might be. Wait, let's just write. So we want to show that MA times MC2 equals NA times NB2. MA is half AB times MC2. Yeah. So I want to get something like AC2 times AB is AB2 times AC. Let's get like that's the dream. Like if that's true, that's really nice, but we might not be able to get that. So NA is half AC times NB2. AB times MC2 is AC times NB2. Yeah, I don't think this is. Yeah, we don't have the length AC2. Okay, wait, let's take this. What if AC2 times AB equals AB2 times AC? Okay, well then, okay, AC2 is nothing but AM plus MC2 times AB, which is AB2 AN plus NB2 times AC. Okay, so 2 AM squared, because AB is 2 AM, remember? Plus, actually, we can just divide by 2 and have AM here and AM here, and we have AM squared plus AM or MA, whatever, MA times MC2 equals AN squared times AN times NB2. And well, yeah, and we want to show that these two are equal. So, yeah, so if BC2, B2C was cyclic, then AB would be equal to AC, and we'd have an isosceles trapezium. Okay, wait, is B2C parallel to BC? That's still nice, right? Like, if that's true. Okay, let's see. Like, maybe that's the thing we need to show. Um, yeah. Okay. Yeah. Like, this is what maths is about at the end of the day, right? Like, you don't know how a problem works, and then you try a bunch of stuff out, and then eventually you get to the solution, or hopefully get to the solution. If you get to the solution, it feels great, and if you don't get to the solution, well, at least you learned, at least you learn more about yourself. You learn more about yourself and how you think, and then and then you gain the ability to solve harder questions. So, the thing standing between me and solving this question right now is, have I done enough geometry questions similar to this? Do I have the right intuition about this problem right now? That I have enough in me to find the right ideas that are going to work? Okay. AC2. AC2. So AC2 is AM plus MC2 times AC. And this is AB2 is AN plus NB2 times AB. Let me divide by 2, AN, divide by 2, wait, AC, yeah, AM. Oh, I think this is actually true because AM times AN equals AN times AM. So we get, no, it's AN times MC2. We need, need, need AM times MC2. Oh, that was almost so nice. Okay, so we don't have the BC2 is parallel to BC. Okay, okay. The other way of showing that MN have equal power is to extend KM to the circle. Let's say let's call this K2 and extend LN to the circle and get L2, and then show that MK times MK2 is NL times NL2. Yeah, okay. I think that let's draw a diagram. Oh, wait, I mean, how long do we have? We have 2.5 hours. Okay. Um, Okay, if we don't solve this in the next 1.5 hours, for the last hour, I'm going to use GeoGebra for this because I kind of want to solve it. At least see if I can solve it. And I think the problem is like this perfect diagram helps, and at the IMO you want to allow GeoGebra, but you're allowed a compass and a ruler. And I don't have either of those right now, so I feel like I'm at a little bit of a disadvantage. But yeah, so for the last hour, I'm just going to use GeoGebra if I can't solve it. So yeah, we have this triangle ABC, and we've discovered that how we construct points A and L is you take a point B1, you draw the circle B1C, something like that, and then you get C1. And then you take the midpoint of AB, take the midpoint of AB, which is N, and the midpoint of AC, which is N. And now we look at the line BB1, look at the line CC1, and we construct, what's it called? We construct L so that B1 and L is cyclic, and L is on C1C. So something like this. Okay. Oh, yeah. And to get K, we well the circle BB1N meets the line CC1 at 2 points. Right now we're only looking at one of them. Maybe the other one is useful. Maybe. Okay. So we have the circle C M. See, I'm just drawing roughly so I can get like a rough position of K. I'm not actually gonna put the circle in. Okay. Yeah. So the main thing really is what are these circles CC1N and what are these circles BB1N? Like, what do they mean? Like, what do they actually mean? I mean, okay. BN and CM meet at the centroid. Yeah, it's kind of looking like okay, and the um, centroid doesn't have equal power with respect to both circles. No, it doesn't because yeah, unless ABC is isosceles. Yeah, I feel like the centroid could be useful here. I don't know, it could be useful. So circle AKL. Yeah, so circle AKL meets AB at C2, AC at B2, and we want to show that MC2 times MA equals NA times NB2. What if, what if C2 is where CK meets AB? That would be really cheeky. If it's true. Okay, if it's true, then okay, so we're thinking about the circles B1N and CC1M. And a few minutes ago I asked myself, what do these circles mean? I mean, A is on the radical axis of these two circles. So let's say the circle BB1 and L. Let's say that's like omega 1 and circle CC1MK is omega 2. So I feel like that's what's really going on in the problem. Then we have A is on the right axis of omega 1 and omega 2 because BC1 BC is cyclic. Or rather, MC1 B1N is cyclic. Yeah. We're thinking about circle AKL. Let's draw this circle in. I think like we need to get to know this circle a bit better. We don't know it that well. Okay, thought one. Does it pass through this intersection point of BL and CK? Maybe it does, maybe it doesn't. Are these three collinear? Another thing that could be true. Yeah. IMO is known as hard for a reason. Problems like this is what IMO is known as difficult. Like, I mean, last year day one, with all due respect, wasn't making anyone think that IMO is harder. Problems like this is why the IMO is considered a hard exam. Yeah. Problems like this, like problems like problem one, even like problem one, like you have to keep having good ideas and then eventually it works. But I think this is a hard geo problem. I feel like this is a hard geo problem. So earlier we had the random observation that MK was tangent to circle CB1K for obvious reasons. Extending MK to meet AC looks like a terrible idea. But we tried an idea we thought was terrible before, and it ended up working. Are we going to do the same thing again? Hmm. I think we really need to get to know Circle AKL. Like, we don't know anything about Circle AKL. We don't know anything about Triangle AKL. Like, A isn't really involved in the problem if you think about it. Like, yeah, it isn't really involved. Like, it's all about B, um, D1, B1, and C. It's about these 6 points, and like they just happen. Like the two lines, BM and CN, just happen to meet at A. Yeah. So okay, we haven't used the fact. I mean, we've used the fact that MN is parallel to BC. Say that A is on the radical axis of those two circles. We haven't used the fact that M and N are midpoints, which is a stronger statement that we haven't used. Yeah. Well, as I said earlier, with midpoints, you can either do homoscity or you can do parallelograms. The parallelogram thing, well, it gave us this like weird cycle, like A, B, L, something. I mean, so it involves A in the problem. So that could be a good thing. Yeah, I'm getting some sun in my eyes. Oh, no, still. Fine. Yeah, it's still a bit dark. One sec. I'm gonna. Oh, yeah. So, circle AKL. Okay, is there any hope of AMKLN being something? Well, let's look at our specific example from before with with the altitude thing. Let's look at that. Okay, if this is kind of where M goes. Yeah, okay, so let's say that what was it like? K is where this circle meets here. This circle meets here. I mean, what are we saying? We're saying like these are going to be cyclic. Okay, yeah. So let's say they are. Wait, could M and LK be cyclic? Maybe. I mean, there's no real connection between M and K. Right? I don't know. There's no real connection between N and K. Yeah. Let's read problem three. In this post-events show, two people have a stick length 1 and want to divide it between themselves. One player marks at most n points on the stick, and the other person also marks at most n points on the stick. The marked points are different. Then the stick is cut at all marked points, creating some pieces. Then they take turns claiming any unclaimed piece of the stick. Each player's goal is to maximize the length of their own pieces. Okay. For each n, determine the largest value C so that the first player can guarantee a length of at least C regardless of how the second player plays. Why does it seem kind of easy? Just upon reading it, my gut reaction is it looks kind of easy. Like um like 95% chance I'm wrong because it's IMO problem 3. But yeah, I'm probably wrong. I mean, there doesn't seem to be anything complicated about how the problem is set up. Like you have two n, you have two n numbers adding to n. Or no, you have two n numbers adding to one. But you have two n points. So you have two n plus one numbers adding to one. And you want to find, and if you select numbers alternating, you want to find the maximum length the first player can guarantee. It doesn't, at least at first, I haven't even started the problem, I'm just reading it. It doesn't seem that complicated, at least upon having read it. But I'm kind of engrossed in this geometry problem now. So okay, so we've got about 2 hours 10 minutes. It's a long time, but in Olympiad maths, that's not that much of a long time. Like, and given combi is kind of my worst topic as well, so I think I'm gonna stick with P2 for another hour at least until the 3 hour mark. I'm gonna stick with Prom 2, and then I'm gonna make a decision at the 3 hour mark whether to look at Prom 3. Okay, so well we were thinking about if MKLN can be cycled. Okay, Well, in all the diagrams I've drawn, it kind of looks like KL is parallel to BC. If KL was parallel to BC, yeah, actually, never mind. Uh, KL parallel to BC. So we'd have the B1 C1 KL is cyclic. So we're suggesting that B1 C1 MKLN are all cyclic. That doesn't seem very likely. But okay, if KL is parallel to BC, then B1L KC1 is cyclic. No doubt about that. Even in the general case, not even a specific case, because of how antiparallels work. And it would mean that Mn is parallel to KL. Yeah, and so we're in that loop again, like Mk equals NL, and then you reflect the thing, and then K prime and L prime are on circle AK prime, L prime, LK. Okay. Okay, so after putting in B1 and C1, we haven't really discovered anything new for like a while. We want to prove some sort of length condition. So looking at things like similar triangles ought to be useful. There's no real like spiral similarity in the compliment. There's nothing like that going on here. But we have those random similar like okay, it's like ABB1 is similar to ACC1. Fine. Um okay. And when we're doing the power of point if we're showing they have equal power by the method I described by putting C2 and B2, we want we want stuff involving lengths MA and NA, which is the same as stuff involving lengths AB and AC. Yeah. Okay, so okay, let's look at okay, what have we done and what have we not done. So okay, let's look at like good stuff we've done and bad stuff we've done. Or like not bad like stuff we need to do. Because of what have we done? We've figured out how to construct an anchor diagram. Construct like diagram. bad thing, we haven't we've only used that, or we haven't reused it. We've only made observations with the fact that MN is parallel to BC, and haven't got anything. We haven't got anything with the fact that M and N are midpoints. What else have we done? We found a viable way of proving the question. So we have a plan of attack. Whether it's a good plan or a bad plan is something we're going to find out. But we have a plan of attack. The main thing we haven't done is we haven't used the fact that M and N are midpoints, and we haven't really involved A. That's another thing. We haven't really involved A. Yes. Okay, we've involved A by saying it's on the radix of the two circles. Fine. Okay, so that's what we need to do. We need to do these things. We need to do these things. Uh, can I read down my screen? Yeah, I can. Okay. So we need to use the fact that M and N are midpoints, not just the fact that M is parallel to BC. Let's kind of draw a circle. Let's actually draw that circle. It might be useful. Something like this. Oh yeah, that's pretty decent for a freehand circle. Um, and then we have the lines BB1, the lines CC1, and we have the circle. What was it like? Oh, B1. Yeah, B1's in United States. It was circle CT1M. Okay, CC1M. Let's actually draw in these circles. It might be useful. I mean, it'd be better if we had a GeoGebra diagram or like a actual proper diagram, but we don't have that. So it's going to be quite messy for now, at least. Okay, and then B1, something like this. Yeah, this is terrible. Yeah, okay, okay. Yeah, it does kind of look like MNKO cyclic. It does look like that. Yeah, I can't. With this, I can't even tell which stuff looks which. Yeah, if I can't tell, like, yeah, I think yeah. When this diagram is not this weird. So, okay, so we need to use midpoints. Use midpoints and use A. And yeah, okay, that's like two things to do. And then the problem should unravel itself. I'll draw the circles with pen. I have a pencil. Yeah, let's use that. Let's use the equipment that we have. So let's go. I mean, and if I draw like a faint circle, that's still fine. Uh, um, uh, yeah, it's not bad. Okay. We have the midpoint. Yeah, let's actually use pencil for this. Yeah, and then we have the line B1 and the line CC1. Yeah, I think. Yeah, and then we have the circle C. Oh, okay. C C1M, something like that. Yeah, that's not too bad. And then it means BB1 at K, I think. Yeah, K, and uh, something like this. Yeah, it's not too bad. Um, Actually, no, I think. Yeah, I think it's that circle. No, I think that circle was quite. Yeah, that circle was not bad. Means here at L. Yeah, yeah. It looks like MNKL is cyclic. But personally, I doubt that. I don't know. I may, I may end up being wrong. Because okay, so yeah, I can't lie. Like, I don't think it's cyclic. Okay, so we said like this one is omega one, and yeah, I think the circle, this one, yeah, that's omega two. Okay. Uh, yeah, it doesn't look too bad. Okay, doesn't look too messy. Um, okay. Yo, wait, this point is on the radical axis as well of omega one and omega two. Yeah, if this point is like, if we say this one's like A two, then A2C1 times A2C is equal to A2B1 times A2B because B1C B1C BC is cyclic. So A2 has equal power to omega 1 and omega 2. Nice. Okay. Okay, I mean, we got so many points on the radical axis of omega 1 and omega 2. Is that radical axis actually useful? Kind of looks like A2 is perpendicular to KL, at least on this diagram. Remember, this point A2 is the radical center of let's call circle BC1, B1C. Let's call that omega. So A2 is the radical center of omega, omega 1, omega 2. Okay. Again, this is just like random observations that I'm making. But again, we haven't used the we still haven't used the midpoint thing. And we kind of need to use that. And we kind of need to use A. And the thing they used both of those things was the things K prime and L prime. This thing. Yeah. That those points used both used A. and use the midpoint condition. So it's not the worst idea to think about these points now as well. Because now we're using the midpoint condition and we're involving A. And we need to involve A because we need to do stuff with circle AKL. Now, like, this diagram is pretty good. It's like the ones we had before, we had no idea how to construct the diagram, so our diagram looked nothing like it should look like. This diagram, it's not a perfect diagram, but it looks kind of like what a perfect diagram would look like. Like everything's roughly in the right place. And it does look like AK prime, L prime is cyclic. Or it looks like you have some cyclic quad involving A and like maybe like A K prime and L prime A cycle. Like something like that. It looks true. Like just looking at the diagram. Okay. I feel like this is like levels harder than any P2 in IMO. Like I don't think we've seen a P2, a medium geometry problem at IMO that's more than 25M. And this I think this is definitely more than 25M. Maybe it is 25M and I'm just struggling, but I think at the moment I think this is more than 25M. So you had a little break from problem two. Okay. Let's okay, we can keep trying to solve this without GeoGebra on this bad diagram, or we can put GeoGebra and we can like put some conjectures and actually see if they're true. So I suspect that AK prime L prime is cyclic. That's what I'm thinking now. And I think the best way to go about proving this is to intersect the circle AKL with AB and AC. Yeah, I kind of want to look at P3 as well, so yeah, I'm going to use GeoGebra. Um, okay. That's fine. Okay. So, yeah, what's going on? Yeah. So we got ABC. We got B1 and C1. Okay. Yeah, because it's very difficult to make conjectures about a problem on a diagram that isn't perfect. Like, okay, so we put the midpoints now, M and N. Yeah, so like now here I can see much better if conjectures. I'm not going to do like the thing where you actually draw in the circle and see if it crosses the thing, because I think that's cheating, but I'm just going to look at the diagram and make conjectures based on that, because that's something you're allowed to do in the IMO. Yeah, and now you have circles. This thing, and where that means BB1, that's K. Yeah, that's K, and then where this circle meets here, that's L. K and L. Okay, so I suspected this thing's gonna be useful. Is this thing Okay, so K and L. And I'll keep this like kind of faint, like dotted, this thing, line thickness, like that. Kind of like there, but not like prominent. Yeah, fine. And then we have like I'll do the same for the other circle. Okay, and we what do? We reflected K in M. And we reflect L in M. Okay, and we have these parallelograms. No. Okay. And this very relevant thing is the circle at AKL, and these points B2 and C2. Okay, yeah. Is KL's kind of looking parallel to BC. KL's looking very parallel to BC. Yeah, KL is looking very parallel to BC. Yeah, this moving B1 is the equivalent of me drawing multiple diagrams in the exam. Okay. The KL is looking very parallel to BC. Is it though? If I move, still looking very bad. Uh, I'm not so sure. Okay, KL's parallel to BC, then KL B1 C1 is cyclic as well, which is big if it's true. Uh, Again, we also have, okay, it looks like AL prime, the circle AL prime LB kind of passes through here. Let's, okay, again, we can draw this circle kind of faintly, just so we have it in mind. Uh, on this one. Okay, this is kind of messy already. Yeah, let's get rid of this. Okay, okay, this is looking fine. Yeah, okay. Hmm. Yeah, this is definitely half pre-two. Okay. If I reflect, we had this idea before that when we had like when we extended BL to AC, we had this idea that the N was going to be the midpoint. That is that true? No, no. I think like drawing lines is fine. Like drawing lines and then measuring equal length, I think that's fine. The KO is looking so parallel to BC. Like it's it's got to be parallel. Like if it's parallel to BC, then yeah, no chance AM and KL is cyclic. That's not true. And these are sort of wrong conjectures we had because we didn't have a good diagram. Okay, we have the okay, never mind. Okay, wait, is the circumcenter of AKL the circumcenter of ABC? Okay, let's construct the circumcenter of ABC. If that were true, this is like unbelievable. Yeah, I don't think it is. Surely not, right? Yeah, okay, surely not. Yeah, fine. Okay, let's put the circumcenter of AKL. Is the circumcenter of anything? No. I think this is legal. Because you have a compass, right? So is, uh, does this circle go through anything else? No. Wait, if I extend BB1, no way. Oh, okay. Yes. 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 Okay, so as I said, we're only considering one of the points on where we're only considering one of the points where circle B1 and LB means C1C. This is the advantage of having the right equipment because you can actually draw an accurate diagram, construct the other point, and see, oh, that point's on AKL as well. Just from drawing the diagram. Okay, so we definitely need to put these points in. Okay, let's say that like say this one's Y and this one's X. Yeah, you definitely need to have these points. So okay. Now okay. Now let's make these cells a bit more prominent. They're a bit yeah, they have a bit let's put okay, okay, let's have it like this. Yeah, now these cells are kind of relevant. Okay. Yeah. It's too many circles. Okay, so this circle, we have this, this, these 5 points. This circle, we have okay, it's K, K prime and L prime really doing anything. I think we've involved a okay. We need to prove that these points are on a circle like K. Yeah, we haven't redone that. Okay, I think let's get rid of K prime and L prime for now. Yeah, let's focus on these points X and Y. Hmm. It looks like um, it looks like B1Y equals B1L. But it doesn't look like C1K equals C1X, so it's probably not true. Oh, okay. Well, we can prove it by power of points from something like B. From B, we have these. Okay, so given that, let's put this one off now because we don't know it's that. And let's okay. So we extend BB1 to meet circle C1 CM X. No, we're doing power of point of C2. We don't know anything about C2. Wait, if we show this aside, are we done? Because we know that I mean we've got the length, right? We've got the length. We've got the length BC2 times BA. Okay, so if we show this, we have that BC2 times BA is twice BC2 times okay, BC2 times BA is Okay, we have B2, but we need MC2, fine. Yeah. Okay. What's the time looking like? Okay, 3 hours, 30 minutes, fine. So look in. Kind of looks like hey, C2 is parallel to to AC as well. Okay, I think the best way to show the okay, I think we can show that X, Y, KL is cyclic by looking at this point A2. If we want to show that if we have that A2K times A2X, we have the A2K times A2X equals equals A2C times A2C1 times A2C equals A2B1 times A2B equals um yeah A2Y times A2L. Okay, so we know that X, Y, K, L is cyclic. We know that. Okay, so we know that X, Y, K, L is cyclic. Fine. But we don't know that it's on circle AKL. We don't know it's a circle through KL that goes through A. Right. Um, how do we show that? Um, yeah, I think this is like my geometry peak if I solve this. Yeah, I don't think I've solved many geometry problems harder than this. Like I remember I solved like um the P3 from 2021, but that took me like 2 3 days to solve that. So if I solve this now, this might be the hardest geometry problem I've ever solved. Like with respect to time. Okay. Hmm. Let's get rid of B2 and C, so now we're doing anything. Uh, okay. I have a suspicion that X and Y are on ABC as well. Circle ABC. You can put that in, right? That'll be in from the start, probably. Okay, yeah, no, it isn't. Fine. Well, yeah, this is definitely hard for MP2. I think yeah, I think boundary for gold is going to be low. I think silver will still probably be. I think silver will be like. I think gold still might be 4 questions. Like yeah, but we're definitely not seeing 5 questions for gold like last year. Yeah, I think there's a chance you might not need to solve this for a gold medal, but there's a chance. But obviously people at the IMO are quite good, so uh, yeah, it's the same for me. Like A is not really there. Mm, the only thing that involved A were the points. Um, oh, I just deleted them. Fine. The points K prime and L prime. Yeah, like nothing else involved A as well. As these points. I don't want to involve A, so it makes sense to put these points. Mm. And we know that A L prime L B is cyclic, and A K prime K C is cyclic. And yeah, I'm trying to work with angle AKL somehow. The only way to work with angle AKL is to work with it as angle A minus angle BAK minus angle CAL. So we have like mm, this is a hard question. Is COK prime? Is that one line? No. I feel like I'm quite close. Okay, let's assume it's on the circle and try and finish the problem. Like if it's on the circle, can we finish the problem? That's a good question to ask. Um, okay. Uh, So again, we put in these points B2 and C2. And we have the power of points from B and from C. We haven't used the M and N and midpoints yet, which is concerning. Maybe we'll use it here. Okay, so let's write down power of points on paper. I can't see my notes. I'm gonna write it down. If we solve the problem, I'll go over it again. So we have BC2 times BA is BK times BX, and CB2 times CA is CL times CY. Okay, so we want to show that MC2 times MA equals NB2 times NA. Okay, BC2 is MA or MB minus MC2 times BA. So BA is just a half MA is BK. Okay, the power of B with respect to. So okay, so let's say like power of B with respect to omega. We'll say omega is no. We said omega is this. Let's say like power of B. Let's just say AKL, and then similarly Na minus N B2 times right, it's not half MA, 2 MA times 2 times 2 NA is the power of C with respect to circle AKL. Yeah, this is so hard for P2. This is really hard for P2. Or I'm just messing up somehow, but I think this is really hard for P2. I think this is unwelcomingly hard for P2. Or I'm messing up. Like, oh, okay. But okay, is okay. So BK times BX is BM times BC1. That should be quite useful actually. Okay. So we have the we want to show, or we know that BC2 times BA equals BM times BC1 because they're both equal to BK times BX, and then BM and BA is 2BM. So I know that 2BC2 is BC1. That seems very useful. 2BC2. Oh, so C2 is the midpoint. C2 is the midpoint of 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 BC1. B2 is the midpoint of C1B. Okay. That is very useful. Um yeah. Okay, I think we should be able to finish the problem from there. Yeah. Okay, so by like direct calculation. Okay, so if okay, so C2 could be the midpoint of BC1. Okay. We'll go back and prove everything. Rigorously, we'll prove that it's on circle like Hale. We have to prove all that stuff, but assuming all that stuff is true, let's progress and try and finish the problem, and we'll come back and show stuff at the end. So, um, Okay, so MC2, we want to show that MC2 times Na equals Na times NB2. That's what we want to show. Well, MA, we know that. But MC2 from our new discovery, MC2 is, okay, so we can split the length AB into chunks. So we got this chunk B2C2, which is X. We have this chunk MC2, let's say that is like A or like M or whatever you want to call it. This chunk MC1 is X minus M. And then we have that X plus M is in the chunk AC1 because M is the midpoint of AB. That bit needs to be 2M. So you have the AC1 is 2MC2. Okay. Okay, yeah, so AC1 is 2MC2. So MA times MC2 is NA times NB2. And then that is equivalent to MA times AC1 equals NA times NB1, which is equivalent to AM times AC1 equals AN times uh, AB1, which is true because the things that okay. So okay, so we've solved the problem if we can show that the second intersection is on circle AKL, and then we're done. Um, hmm. This is the very good advantage of having a proper diagram with a compass and a pen and a ruler and stuff. But I don't have my ruler. I have a compass, but I don't have a ruler, and I don't want to I don't want to try and try and use something that's not a ruler as a ruler and like mess that thing up as well. So okay, so we can get rid of B2, B2. Wait, oh wait, did we prove that C2 is midpoint of BC2, BC1? I don't think so. Yeah, I don't think we did that. We kind of, I think we reverse engineered it. Wait, so we had BC. Oh no, no, we didn't reverse engineer. We had it. We got it from. We got that thing. We got that fact from the fact that C2AKX is cyclic and KMC1X is cyclic. So we didn't we just need to prove that X and Y are on cyclic AKX. We don't need B2s. We don't need C2. We don't need O. We don't need any of this stuff. We just need to show that X and Y are on circle AKL and we're done. Okay. Yeah, I'm very curious to see how many solves it's gonna have the IMO. Like, okay, but the thing we still haven't proved is KL parallel to BC? Like, it looks so parallel. Like, but okay, well, I can't say if they're parallel. Like, well, I can extend KL and see if it meets BC. Because you can do that. I think it does. Okay, so KL is not parallel to BC. Okay, fine. Fine, fine. Okay. Yeah. Okay, let's really think. I think we really think hard about this. Uh, okay, circle CC1M means BB1 at X. Okay, do I even need K and L? No, I definitely need K and L, right? Yeah. Okay. Um, okay, I don't need Y though. I just need if I show X on the circle, that means Y is on the circle as well. So let's not have Y. I need C1 and B1 to define K and L. Okay, we just need to show X is on the circle. Okay, let's draw in XA and XL. Yeah. Okay. Okay. This is actually so hard. How are we doing for time? Okay, 3 hours 40 minutes. Okay, so we don't have that long to talk. We need to write it up as well. Okay, I think I'll take two problems. I'm not gonna answer question three. I don't think because like solving this and writing up, I think it's gonna take like 30 minutes. So yeah. Mhm. Like one proof. We need to prove one thing, and we're done. Okay, is A2 gonna be useful for this proof? No, it's not gonna be useful. So let's get rid of A2. A2 played its role. Are M and N gonna be useful? Well, M and N define like M and N, well, like the whole thing, right? So we need to have M and N. Oh, this is like wow. What a problem, honestly. What a problem. Well, yeah, again, we don't have A anywhere. If this bet, hopefully this is not just angle chasing. Like if this is just angle chasing, like that's just like no way, surely not. Okay, so KL isn't parallel to BC. I mean, sure that AKLX is cyclic, and that's the whole problem. Okay, is it a Mikkel point? If X could be a Mikkel point, right? Um, no, but then X one needs to be on like AMN or something. Yeah, and if X is on AMN, Y is on AMN. And AMN can't meet circle AMN can't meet circle AKL at AX and Y. Um, it's not circle AC1B1. Is there anything else I can prove about X? Like anything else? Can we use a sine rule to throw it? Maybe. Maybe. You know what? Actually, no. Um, yeah, this is like okay. Okay, so what was this? What was this thing about? This thing is about the line BB1. That's what it's all about. K is on that line. X is on that line. Like that's what this is about. BB1. That's like the central to the. That's what's holding the whole picture together. Maybe consider the circle ABC. Like I don't know. I'm just like thinking random stuff. Um, mm, maybe extend BN and CN. You know, extend BL. No. Yeah. Okay. So we don't know how to work with A. We want to show the external circle with A. So we need to find some other nice point on the circle. Maybe where the right axis of this thing meets the circle here. Maybe this point. Yeah, I had a conjecture the right axis is perpendicular to KL. Is that true? How can I verify that with legal equipment in the IMO? Just staring really hard at it doesn't count. Um, okay, well, I can put the circumstance of these two, um, and then draw these two lines and see if they're parallel. Oh, yeah, they don't look parallel. They look like they're gonna meet somewhere. Yeah, they look. You can tell without even seeing the intersection point that they're gonna meet somewhere. Okay, fine. So KL is not perpendicular to the right axis. Okay. Yeah, this is really, really hard. How are we doing for time? I think we might run out of time. Just at the end, okay. 30 minutes. We need to show the AXLK cyclic. Wow, okay. Again, we haven't used A. We need to use A. Okay, we've got 30 minutes. Oh, wait, it means BB1, the line BB1 is the radical axis of AKL and omega 2. Okay, wait, what do we know? We know that, okay, how are we gonna get the power of, okay, let's suppose we forget, I mean, can we show K is on the radical axis of it? If we show the, I mean, K is gonna be, if we show the 2 points on the line BB1 have equal power to circles AKL and C1M, we're done. Okay, so what do we have? Well, we have the power of B, the power of B to circle, to circle, to omega 2 is BM times BC1. Okay, do we know the power of B1? No. To circle AKR, we don't. Okay, but we know the power of B1. Um, do we know the power of B1 with respect to omega 2? Okay, wait, hold on. If B1 has equal power with respect to 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 omega 2 and AKL, again, if we put these points, for this point B2, we had B2 as a midpoint. Okay, so rather let's forget about X. Let's forget about X. Like let's focus on showing the B1 and B. Yeah, like AKL is such a random circle. Like how do we do anything with it? Okay, and the power of B1 to this circle. Okay, what if we put in a point B3 here? B3. And we want to show, and this one's B2. And we know that B2 is the midpoint of CB1. So, oh, okay, so B3 should be the midpoint of AB1, because we need B1A times B1B2 equals B1B3 times B1C. So B1C is twice B1B2, so we need B1B3 to be half B1A. So B3. Okay, so many midpoints. Wait, but hold on. We know that B3 is the midpoint because AC1 times AM is AB3 times AC, and AC1 times AM is AB1 times AM, which is a half AC times B1. And we know that AC times AB3 is AC1 times AM, which is AB1 times AN. And since AN is half AC, we need AB3 to be half AB1. Okay, so we actually know that B3 is the midpoint of AB1, given how it's defined. Okay, so all we need to show it is if B2 is the midpoint of B1C, the A B2LK cycle, but that seems just as bad. That seems just as bad as showing X lies on that circle, AKL. Like, I don't think this point, like, AKL is such a random circle. Like, Okay, okay, when calculating the power of B, we use C2. Oh, how much time is left? Okay, we still got like 18 minutes. Fine. Okay, so BB1 is if we define B2 as the midpoint of CB1 and C2 as the midpoint of BC1, we know that BB1 is the radical axis of circle AB2C2 and CC1M. Okay, but I don't think this point is going to help us anymore. Do it if I put C3 here, because of power of points, we know that AC3 times AB. We know C3 is the midpoint as well. Midpoint of, yeah, of AC1 and AB1. Surely that means B3 C3. B3 C3 C2 B2 should be cyclic, right? Surely. Um, no, but that would mean that B2 C2 is parallel to BC because of anti-parallels, which you know isn't true. Um, but like, circle AKL. This is a nightmare of a problem to. How much time is left? 15 minutes. Okay. BB1. Yeah, because the only meaning of X and Y were really to calculate the power of B with respect to those circles. So we know that BB1 is the radical axis of circle A, no, of circle B3 C1 M K C and AC2 B2. We know B1 BB1 is the radical axis of that. But we need to show BB1 is the radical axis of circle AKL and B3C1MC. That's such a hard problem for P2. I don't remember having ever struggled this much on a geo problem. Like, like either I solve the thing quickly or I solve it after like 2 hours or 2.5 hours, but we're almost at 3 hours here. And I feel like I, I'm basically there. I feel like I have everything here and like I can't see it. How much time's left on? Okay. Oh, okay, okay. Not long. Not long. Um, wait, wait. BB1. Wait, but okay, wait. So K. So I have BB1. Wait, what if we show that K is on circle AC2 B2? Well, yes. Wait. There's no way. There's no way. There's actually no way. There's no way. Oh, wait. There's no way. Oh my. Oh, it was right there the whole time. It's that line BB1. BB1 is the radical axis of AC2 B2 and CB3 C1 M. And K is the point where BB1 meets circle CB3 C1N. And K is on the radical axis. So K has to be on the other circle. Right, where the radical axis of two circles intersects one circle is got to be on the other circle as well. And that's the same thing is true for K. Okay, yeah, okay, so we're done. No, okay, we don't even need. Do we need B3 and C3? Yeah, to show we need B3 and C3 to show that BB1 is the radical axis. But that bit wasn't too hard. The main of like B okay, so BB1 is not the radical axis of AKL and CB3 C1M. It's the radical axis of of AC2B2 and CB3C1M. And where BB1 meets this circle is K. So K's gotta be on AC2B2. Okay, let me write this stuff up. So BB1 is radics of when I have to say like by things proved earlier, B has equal power to circles um, A, B2, C2, and C1, CM. Consider B3 the midpoint of AB1. Okay? Um, AB3 times AC is equal to a half AB1 times 2AN, which is AB1 times AN, which is AC1 times AN. So B3 is on AC1 and C. So, moreover, BB3 times B1 B1B3 times B1C is equal to a half B1A times 2BB2 2B1B2, which is B1A times B1B2. So B1 has equal power to circles A, B2, C2, and C, C1, N. And then and K is where BB1 meets circle CC1M. So K is on radics. So AC2KB2 is cyclic. And then uh, by similar argument, AC2KLB2 is cyclic. So BB1 is radics of AKL and CC1M, so AXYLK is cyclic. Alright, fine, okay. Okay, what a problem. Oh my days. That's gotta be the hardest problem too. The hardest medium geometry problem ever. I'm gonna go and look back. I'm gonna go and take a look at the past IMO papers and which ones had medium geometry. Last year's geometry was nothing compared to this. 2024 wasn't a P2 or 5. 2023 is again nothing compared to this. Um, I'd say like honestly for me this is comparable to 2021 IMO P3. At least for me, like in terms of difficulty. Like, if you know inversion, I'd say this problem and 2021 IMO P3 are the same difficulty. Like, yeah, because that one took me three days, but I think I was a lot worse at geometry when I was solving it. Like, this one, if you gave this one to me back then, I would have taken a similar amount of time, maybe a bit less time, fine. But this is a hard I think it's comparable. I think the two are comparable, honestly. Like, yeah, yeah, this is so hard. Like, I'd say this is this is closer to the level of a P3, P6, of the average geometry P3, P6, than to the average geometry P2, P5. In my opinion, like, yeah, this is similar to the difficulty of 2015 P3. I don't even think that's controversial. That can't even be controversial. Like, yeah, that's just facts, right? Like, maybe yeah, I'd say it's a bit harder than it's not a bit, it's quite a lot harder than 2012 P5. Like, I'd say yeah, that one is still easier than this. Like, this is like you have two random points KL and you have midpoints. Like, what's going on? Like, yeah, this is so hard, honestly. Like, yeah, 2010 IMO pizza, like it's nothing compared to literally. Like, I don't think a single medium problem is even half as difficult as this. I'd go that far. I'd go as far to say as no other medium geometry problem on IMO is half as difficult as this. Like, honestly, this is like okay. Let's go back through the solution again. So what do we do? So we had AKL, we had KL, these random points defined by uh, by these like random equal angles. Like, okay, maybe looking back, constructing B1 and C1 isn't that crazy. Like, yeah, it's not that crazy, fine. But yeah, I say constructing B1 and C1 isn't that crazy. And then you have circles C and KC. Yeah, I probably would have got B1, C1 a bit faster usually. Usually out of my first thing would have been to construct B1, C1. But yeah, that took me way too long to get. But then like even then, I'd say maybe maybe I'm exaggerating quite a bit. But even then, like I think this is hard. Even then, because I mean, circle AKL makes sense, but even I don't know if there's a better solution. But the way we deal with circle AKL is by defining it as a completely different circle. We don't work with circle AKL. We work with circle A AC2. We work with circle AC2B2. We work with circle AC2B2 and make sure the KL are on that. Like, I don't know, that's crazy. That's yeah, that's like yeah, I don't want to say I've never seen this in a problem before, but I've never seen this. I think the last time I had something like this and a problem was some like I think it was maybe a Japan Olympiad question. Like how like this is crazy. This is mental. Like you forget about circle AKL. You work with circle AC2B2. You show BB1 as the radical axis of that, and then that tells you K is yeah, that is yeah, that's mind-boggling. That is crazy. Right, yeah. That's the that's the end of day one. I think we don't have time for P3, okay. Yeah, that's the end of my day one attempt. Um I'm pretty happy with it, to be honest. I mean, we got P2 in the end. That's what matters. Like, yeah, if they're putting a P2 geometry, I would be quite disappointed to not solve it. But it was like this. Yeah, I'm really interested to see how many people solve this. Like, I don't know. Like, like maybe a lot of people will solve this because actually, yeah, looking back, okay, it's hard, but like it's doable. It is doable. I'm not gonna say it's impossible in the IMO as a medium. I'm not gonna say it's impossible, but it's reaching towards the P3, definitely. Yeah. Okay. Yeah. See you guys for day two.